So, hello everyone. Let us discuss a new topic about constructing the binary tree using the tree traversals. So, in this video, we'll be discussing about constructing a binary tree by use of the in-order and the pre-ordered tree traversals. So, in the binary tree, we can construct the binary tree by use of the two tree traversal results. Generally, what are those traversal results? First one is the in-order and the pre-order traversal. That means if the in-order and the pre-order traversal of a tree is given or binary tree is given, we can construct the binary tree back from it. And similarly, we can have the use of in-order and the post-order traversal. So in this video, we'll be covering the first part, that is the in-order and the pre-order traversals. So how we can construct it? Before that, what these traversals tells us about while constructing the binary tree. So the pre-order and the post-order traversals will help us to identify the root node of the binary tree, or at any particular step what will be the root node out of the given or the out of the chosen respective nodes that will be identified from these post-order and the pre-order traversals. Then in-order traversal will help us to identify the left and the right child nodes for a given root node. So if we know a given root node, so what will be the left subtree of it, what will be the right subtree of it, we can identify by use of the in-order traversal. So let us see how it helps us to identify these things. So these are the generic tree traversal which we have. For in-order traversal processing, if a tree is given, we can process the in-order traversal by use of these rules. So first the left, then root, and then the right node is traversed. Similarly, in this case, pre-order, first the root node, then left node, and then right node will be processed. Then in the post-order traversal, first left node, then right node, and then root node will be processed. So suppose this tree is already given and we want to generate first the traversals. Then by use of the traversals, we can regenerate the tree back again. So as per this particular tree which is given to us, in-order traversal will be like this. How it is evaluated? As per the rule, we start from the root node of the tree, as the tree is already given. So the root node is A, this one. So we start from this and apply this rule which is given here, that we have to process the first left part of it, then root node will be processed, and then right node will be processed. So this rule will be applied to each and every node which is encountered in this particular tree. So we start with this root node which is A for in-order traversal processing. So we go to the left part of it first as per the rule. Then again on this B node, we have to again apply the same rule of in-order traversal, which is we have to again go to the left part of it. That's why B is the first node which is processed, as D doesn't have any other left and right part. So this D will be processed as a root node because there is no left and right part. That's why they are not processed, and ultimately the root node is processed out of this particular given thing. So that's why D comes first. Then again it will go to the root node of this particular D node, which is B. That's why B is processed after this. And then we have this particular node which is E, which is processed after this. Then we come to the right side of it, which is this part. And before that, we go to the root node, which is processed here as A. Then we go to the right part, which is FCG. How it is processed? First, the left part of it is processed, which is F. Then the root node of this is processed, which is C. Then the right node of this is processed, which is G. So this is how we get the in-order traversal of a particular binary tree. Similarly, on these lines, we can retrieve the pre-order and the post-order traversal for this particular given tree, as per the specific rules given for these traversals. So pre-order will be like this, and post-order will be like this. So these are the two traversals which are again calculated based on these given rules, which is root left right and the left root right. Then what is the advantage, or what is the thing which we can get from this pre-order and post-order traversal? As we have said earlier, this pre-order and post-order traversal will help us to identify the root node of a given binary tree. How? As we can see, the root node of this particular given binary tree is A. So how this pre-order traversal tells us which is the root node. So in every pre-order traversal of a binary tree, the first node or the starting node will be the root node as per the traversal. Because in pre-order traversal, we first process the root node of the given tree. And the similar case is with post-order traversal. In post-order, we process the root at the end. So that means for the complete tree, even the root node will be processed at the end. That's why this A is given in the end. So in case of post-order traversal, last node is the root node. And in case of the pre-order traversal, first node is the root node. So this is how we can identify from pre-order and post-order traversal which one is the root node. And if I see this in order traversal, in that case, I can see that if we know whatever is the root node, I can identify whatever is left part and whatever is its right part. So if a given root node is provided, I can identify from this particular traversal, like this A is the root node in order traversal here. So DBE, these three nodes will be the left part of this particular root node A, and FCG will be the right part of this particular root node A. Okay, so this is how in order traversal will tells us about the left and right subtree of a particular given node. Okay, so let us start converting the binary tree or generating the binary tree by use of the in-order and the pre-order traversal. So we are taking the same example as we have seen right now, but now we have to reverse that operation of generating the binary tree by use of the given traversals. So these are the traversal results which are given to us. Now we have to create the binary tree out of it. So as A is the root node of the binary tree, so as per the rule of the pre-order traversal, first node will be the root node. So this means that A is the root node because in the pre-order traversal, it is the first node which is encountered. So now we are able to identify that this A is the root node of the binary tree which we have to construct. Now what will be the left subtree and what will be the nodes in the right subtree? We have to identify next. So for that we have to check the in-order traversal. So A is our root node and we have to identify its left and right part. So as per the rule, this will be the left part and this FCG will be the right part corresponding to this node A. Okay, so this becomes left part and this becomes right part as per the rule. So let us see that this is the final binary tree which we already know, but how we construct it? First we start with A, then we know that this D, B and E will be the left part as per the in-order traversal, this one, and this FCG will be the right part again as per the in-order traversal. So out of this D, B, and E, which one will be the root node? How it is decided? Again, we have to go back to the pre-order traversal. So out of these three nodes, D, B, and E, which one is the node which is coming first? That will be the root node because of this particular rule. This root is processed first, then the left, and then the right part. So out of this B, D, and E, B is coming first, so it will be the root node. That's why B comes here as the root node. Then we have to again identify which one is the left and right part of B. So we again go to the in-order traversal and see that D is the left part and E is the right part of this particular node B as per the in-order traversal. So that's why D comes on the left side and E comes on the right side. Similarly, if I can see this FCG, out of this FCG, which one is the root node? We have to go to the pre-order traversal because pre-order can tell us the root node out of this FC and G. So we can see out of this FCG, C is coming first. So that's why C is the root node out of this all three elements or three nodes. So out of this FCG, C is the root node. Now we have to identify which one is on the left and which one is on the right of this C. So again, we have to go to the in-order traversal. So as per this in-order traversal, C is here and the left part is F, right part is G. That's why left part here is F and right part here is G. So this is how we can construct the binary tree by use of the in-order and the pre-order traversals. Next, this is given as a practice exercise which you can try out yourself to make it more clear. To start with this particular exercise, I can tell you a hint about it. Like, as this is the pre-order traversal, so 1 is our root node as per the rule, and we have to identify its left and right part. So as per the in-order traversal, this is the root node. So that means 6, 3, 7 are on its right side, and these elements are on its left side. And again, we have to identify from 637 which one is the root node. So again, we go to the pre-order traversal. So 3 is coming first. So 3 will come here as the root node, and 6 and 7 will be on its left and right as per the in-order traversal. Okay. So 6 is here and 7 comes here as per the in-order traversal, as 3 is the root node. So 6 is on its left and 7 is on its right. So this is how we can construct the right part. Similarly, you can construct the left part of this particular traversal. Thank you.